Hello friends, grab your coffee, grab your cookie, and today please keep both far away from any electric arc furnace because we are talking about one of the toughest, strongest, most heat-resistant filter materials in the dust collection world, Aramid felt, also known as Nomex. If polyester is the workhorse and cotton is the classic, Nomex is the firefighter. It thrives where everything else melts. I am Michael Klepik, and for 15 years I have been designing baghouses for metal foundries, high-temperature dryers, mineral plants, and chemical operations. Today, I want to show you why Aramid is the go-to material when temperatures climb and dust becomes brutal. What Aramid, Nomex, filter media, really is Aramid felt is a high-performance synthetic fiber made from aromatic polyamides. In simple terms, this fabric is engineered to survive extreme environments. It offers, first, a maximum continuous operating temperature of 375 degrees Fahrenheit. Second, excellent strength at high temperatures. Third, outstanding resistance to abrasion. Fourth, stability under strong mechanical pulsing. Fifth, resistance to dry heat degradation. Nomex is not a fabric. It is a survival tool for harsh industrial conditions. Where Aramid filter bags are used, Nomex is designed for environments where other filter materials fail. I typically use it in, first, electric arc furnaces producing steel or specialty alloys. Second, cupolas in foundry operations. Third, high-temperature rotary dryers, asphalt plants, and mineral kilns. Fourth, abrasive dust environments where fibers must resist wear. Fifth, chemical applications involving hot exhaust streams. Sixth, high-temperature baghouses with heavy pulse jet cleaning. Seventh, thermal processing lines with aggressive airflow. If the air is hot, dry, and abrasive, Nomex usually wins. Why Aramid works so well in extreme dust conditions. Aramid fibers have unique thermal and mechanical properties. First, they maintain strength at elevated temperatures. Second, they resist hot gas flows without losing shape. Third, they withstand repeated pulse jet shock waves. Fourth, they resist abrasion from hard minerals and metallic fines. Fifth, they maintain filtration efficiency even under thermal stress. In other words, Nomex keeps working long after other fabrics burn out. Temperature and chemical limitations. Nomex is strong, but it is not invincible. Limits include, first, it cannot tolerate high moisture at high temperature. Hydrolysis will destroy the fabric. Second, strong acids will break down Aramid fibers. Third, strong alkaline environments shorten filter life significantly. Fourth, it oxidizes when exposed to high oxygen levels above its temperature rating. Fifth, it should not be used in wet or sticky dust applications. Nomex loves heat, but does not love chemistry. Behavior of Aramid in airflow and filtration. When operating inside a baghouse, first, Aramid maintains stable airflow at high temperature. Second, it forms a uniform dust cake that improves filtration. Third, pulse jet cleaning works extremely well due to strong fiber recovery. Fourth, it handles abrasive dust without rapid wear. Fifth, dimensional stability prevents stretching or shrinking inside cages. This media is predictable even under chaotic process conditions. Which torch air systems use Aramid media? Torch Air installs Nomex in several high-temperature dust collector models. Blizzard high-temperature pulse jet baghouse used for arc furnaces, cupolas, and steel-making exhaust. Blizzard thermo-dry baghouse used for asphalt plants, mineral dryers, and cement kilns. Achman high-wear cartridge system used when abrasive, high-temperature dust requires extreme durability. Custom furnace exhaust systems built for foundries, chemical reactors, and metal processing operations. If your process runs hot, Nomex is usually my first recommendation. OSHA and NFPA compliance Aramid filter bags help meet, first, OSHA particulate exposure limits for mineral dusts and metallic fumes. Second, NFPA combustible dust guidelines in high-temperature production lines. Third, foundry ventilation requirements for arc furnaces. Fourth, emission standards for mineral and metal processing industries. Fifth, general industrial compliance where temperature-resistant filtration is required. Nomex is a compliance-friendly material when the right conditions are met. Dust collector system design considerations. For Aramid filtration systems, I designed a baghouse with extreme durability in mind. First, differential pressure sensors rated for high-temperature operation. Second, heavy-duty pulse jet valves to clean dense felt at elevated temperatures. Third, high-temperature cages to prevent bag distortion. Fourth, abrasion-resistant inlet baffles for furnace and mineral dust. Fifth, high-temperature gaskets and seals to prevent heat loss. Sixth, automatic hopper discharge systems to remove hot, heavy particulate. Seventh, spark and flame-resistant system components for metallurgical environments. Nomex works best when the entire system is engineered for heat. Aramid, or Nomex, is the heavyweight champion of high-temperature dust collection. With a maximum continuous temperature of 375 degrees Fahrenheit, excellent abrasion resistance, and unmatched durability in extreme environments, it is the go-to media for furnaces, dryers, cupolas, metal shops, and high-temperature process lines. I am Michael Klepik. Protect your lungs, protect your equipment, and remember, when the heat is on, Nomex is the one thing that should never melt. See you in the next video.